2, 1. Hi, I'm Gia Zedlia. I'm part of one of the senior groups presenting today here at the Fischell Department of Bioengineering.
Hi, I'm Ishmael Paryavi. I've been working on a project to develop a new therapeutic device which we call the endotracheal aerosol generating catheter.
Hi, I'm Kelsey Harrison with the Bioengineering Department at the University of Maryland, here today presenting my capstone project for our senior year.
Push it through the endotracheal tube and it comes out the other end.
These are the nerves that we're trying to identify.
In 3 years of studying engineering, students rarely encounter real-world engineering problems to solve.
On the other hand, in the medical center, we find problems all the time that we don't know what to do with, and it seemed to be a logical marriage of docs who can recognize problems and bring them to the engineers who can solve them. We announced that there would be the opportunity for these groups of students to rotate through our units and our specialty laboratories to get ideas and talk to the clinicians.
It's a terrific opportunity for these students to actually interact with medical staff, physicians, nurses at all levels, technicians, and to understand in great detail what problems are out there, what problems need solutions.
I can tell you with my own group, they came up with some ideas for solving problems that did not exist in clinical medicine, and I had to tell them that, and we came up with a problem that really did exist, and they went to work on it, a method for delivering aerosol medication to patients who have breathing tubes in, endotracheal tubes.
Usually when that's done, a patient is what we call intubated, so they have an endotracheal tube, which is this outer tube here, placed through their throat and connected to a ventilator to control the flow of air and other materials going in and out of the lungs, basically life support. So usually while patients are on this kind of life support, they also need drugs delivered. And the way that's currently done is all drugs are delivered at the proximal end, so they're delivered outside, and it's hoped that that gets to the lungs. But studies have shown that really only 1 to 3% of that drug ever reaches the lungs. So what we're developing is what we call the endotracheal aerosol generating catheter. And this is a catheter that goes through the endotracheal tube. It's right here. We push it through the endotracheal tube and it comes out the other end. And it aerosolizes drug, it nebulizes it at the distal end, so within the trachea, as close as possible to the lungs.
My group was working with image processing to perform ultrasound-guided nerve blocks. Anesthesiologists often use ultrasound in order to locate the nerves for this procedure, but the unfortunate problem with this method is that the nerves vary greatly depending on the person. They vary in size, angle, location, etc. So the person has to be very well trained in order to successfully locate the nerves. Unfortunately, anesthesiologists aren't always available to perform the procedure. So in order to address this need, my group and I developed an algorithm in a program called MATLAB that essentially processes the ultrasound images in order to locate and identify the nerves.
We found an unmet need for a cervical brace for patients suffering from degenerative joint disease or from whiplash. Most of the solutions for patients such as these are either soft collars, which only serve as a reminder not to move your head, or hard collars or traction devices, which are frequently painful and require the person to not have any instability or adjustability while they're in the device. They cannot do anything else while they're wearing it. So we came up with a redesigned neck brace.
collaboration between the Medical Center and the School of Medicine and College Park is great for the school, both schools. It'll be great for the state of Maryland because these are homegrown talent.